All right, I believe we are live today for Hoot episode 55. Welcome, welcome. Today we're going to talk about Cilium CNI 1.14. The biggest news for the past week is Cilium 1.14 went out a week or two ago, I believe. Really, congratulations to the entire Cilium community on achieving such a big milestone. I don't know if you all seen last year per Cilium's annual report, Cilium and the recognition of CNI, Container Network Interface, for the year. Well, many of us really believe Cilium is become the de facto standard for the CNI. So I have been playing with Cilium CNI 1.14 myself. Um, I just a second. If you are not talking, just put on mute. There's some background noise. So I have been playing with Cilium 1.14. I'm very impressed of how easy it is to use, and I'm so excited today. I am also having two of my coworkers, Daneyon and Jason, join me to discuss about Cilium CNI 1.14, how we could potentially layer Cilium with Istio's policy to achieve defense in-depth security best practice. So I'm really looking forward to chat with Daniel and Jason because both of them know a lot more about Cilium than me. So I'm excited to learn quite some about Cilium and particularly 1.14 from them. So before we jump to the topic, Daniel, can you quickly introduce yourself to the audience?
Yeah, sure. Thanks, Lynn. I'm Daneyon Hansen. I am a software engineer with Solo. I have been a software engineer for quite some time, working in Kubernetes as well as several other CNCF projects, maintainer of Gateway API, Contour. So been working in this space for a while, and even before then, started my career in the networking world, which we'll talk more about networking here in a minute.
Awesome. Thank you so much, Daniel. Jason, do you want to do a quick intro also?
Hey everyone, my name is Jason Skrzypek. I'm based out of Buffalo, New York, if that matters to anybody. I'm a sales engineer at solo.io, and previous to that, I worked in several CNCF level startups like Rancher. I worked with Red Hat, so I've got a deep experience with Kubernetes, and Cilium keeps popping up, and I keep enjoying my use cases with it. Hopefully, we can talk more about that later today.
Awesome. Thank you so much to both of you. Let's see. Let's talk about Cilium CNI 1.14. What are the features of Cilium CNI 1.14 that excites you? I guess I can start first. So for me, I feel the Cilium CLI was very, very easy to use, and particularly the installation to have Helm embed into it was very exciting. I've also been playing with the deny policy, which I believe recently graduated to stable. So that was very cool. The Hubble UI is always cool, even though I don't really know what's new for 1.14, but it's very impressive, very easy to use. What's some of the favorite feature from your perspective, Daniel?
Yeah, so from my perspective, there's been some things that I've been involved with as a contributor of Cilium that I'm a little partial to, and that is around BGP and IPAM. So BGP, which we'll dive into in more detail here momentarily. There's been a lot of work from the community around enhancing capabilities of BGP, making it more configurable, making it easier to operationalize, and just adding functionality around BGP. And then with IPAM, there's a few pieces that have been added for multiple pools, so what's being called multi-pool IPAM. This is going to help where there's requirements to have pods with multiple network interfaces. And then a new way of integrating IPAM with BGP called LB, or load balancer IPAM. We'll talk about more in a minute.
That's awesome. Sounds like a lot of things I need to learn from you, Daneyon. Jason, what about you? What are the new features from 1.14 that excites you?
As a sales engineer, and knowing what I do about Cilium, I'm always trying to bring people into the light, as it were. And so making Cilium easier to install, or being able to migrate from the legacy workloads or legacy CNIs to Cilium as a CNI, it's really helped me start to introduce people to Cilium, as well as some of the Helm changes that they've made, embedding the client. It just makes it super easy to get people up and running in environments that might have a little bit of cruft in them.
Totally agree. Yeah. So, Danny, you talk about BGP. So, for folks who are not very familiar with BGP, can you explain what BGP is and why somebody would consider using Cilium and BGP?
Yeah, and I think before we get into BGP, it's important to just kind of have a primer on networking and routing and so forth. And so I put together, let's see here if I can share here. I put together some slides just to help me kind of talk through this. Is everyone able to see my screen okay?
Yeah.
Awesome.
Okay. Thanks.
So really quickly, like I said, before we get into BGP, I think it's important just to establish a baseline, and that is around networking, right? And so when we're on our laptop and we're a client and we're going to somewhere on the internet, all right, we're typing in a URL, and that's a DNS name that gets resolved to an IP address. And then we as a client start sending packets to that destination. All right, and in this simple example, right, the client and the destination, they're both on the same network, and so they're able to communicate directly with one another. When the web server in this example receives the the IP packets, it decapsulates those IP packets, pulls the data, and then the application reads the data. But in reality, this is what it looks like in typical networked communication. Right, you have your client and your server on two different networks, typically interconnected by a bunch of different networking devices, particularly routers. Right, and the routers are represented as these blue circles. And what happens is your client, when it goes to communicate after resolving the destination name to an IP address, it will say, wait a second, this destination is not on my network, so I need to send it to my configured default gateway. And we'll go ahead and forward the packets instead of directly to the destination. We'll forward it to its default gateway, which is typically, again, a router. And then the router goes ahead, receives this packet on one of its interfaces, reads the destination IP, and then forwards that packet along. And the process just continues to repeat itself until you see on the left-hand side where the final router reads that destination and says, "Oh, that destination's off this interface," and send it to this host. But one of the key aspects here is something called a routing protocol, right? And that is, well, if you have all these different routers, all these different networks, how do the routers here on the right-hand side of the screen learn about all these other different networks over here on the left-hand side of the screen, right? And that's where routing protocols come into the picture. And so a routing protocol is a process that runs on each one of these routers. And it is responsible for communicating with other routers here and saying, hey, router, this is the networks that are directly connected to me. These are the networks that I know of, and sends them to the adjacent routers. And what does a router do with this information? It builds what's called a routing table. And that routing table is network, a next hop to get to that network, and outgoing interface. And so when you kind of bring all that together of routers being interconnected and routing packets based on routing information, learned from routing protocols, and then forwarding those packets. So now we've got a basic understanding of routing, networking, routing protocols, and now we start to get into BGP, right? And in order to understand BGP, we talked about routing protocols, but routing protocols are actually classified into what's called IGP, or an interior gateway protocol, or an EGP, an exterior gateway protocol. And interior gateway protocols, examples are OSPF, ISIS, IGRP. These are protocols that run within an organization, like a large enterprise, because the enterprise has full administrative control over how routes are selected, and how routing peers are authenticated with one another, and so forth, right? And so that's what an IGP does. Whereas an EGP, it's responsible for communicating within or between large enterprises, between internet service providers, and what are called autonomous systems. And so autonomous systems are a grouping of routers that are under a common administrative domain. And so you see in this example, we have 3 different autonomous systems, 1, 2, and 3. We've got a few routers in 1, 3 routers in 2, and 3. Typically, autonomous systems are going to be a collection of tens of hundreds of thousands of routers that all make up this autonomous system. And autonomous systems numbers are actually similar to IP addresses, in the sense of, if you want a public IP address, you go to ARIN, and that's the authority that assigns publicly routable IP addresses. And ARIN handles the same responsibility for these autonomous system numbers, right? And so with BGP, it is a protocol that's used to communicate between autonomous systems, routers that communicate with the different autonomous systems. And so that leads us into what BGP looks like at scale, right? So you could think of each of these autonomous systems, and there's many more than what's represented here, but each one of these autonomous system numbers, again, could be made up of hundreds of thousands or more routers, each router having several networks. And now we start to think of what the internet is. And when we think of the internet, it's BGP, TCP/IP, DNS. I mean, those are like the core services that have allowed the internet to scale and be what we know of it today. And so what does this mean for Cilium, right? And so BGP for Cilium provides a mechanism or a way to advertise service IPs or pod CIDRs within your Kubernetes cluster. Now, typically, this is not needed if your Kubernetes cluster runs in a cloud environment, right? So your cloud provider, it takes all of this kind of complexity away, and you say, hey, let me create some pods, let me create a service for the pods, and the service automatically gets an IP address, and I'm able to reach that IP address from my home laptop, for example, right? And it's like, whoa, how did that actually happen? And so the cloud provider is able to implement things like BGP and all sorts of other mechanisms to make that service IP address, to assign the service IP address, and then make it routable within not only the cloud provider's network, but advertise that address to other cloud providers. And so it's reachable from anywhere in the world.
So the Kubernetes service IP here doesn't mean my internal service to my Kubernetes cluster. Is that fair assumption? It means the services who wants to be exposed outside of the cluster.
Yeah, so this would be services of type load balancer.
Got it.
And again, BGP for Cilium could not only advertise the service IPs for load balancer services, but it could also advertise full pod ciders. And we can show that potentially in the demo, but just know that BGP is essentially like an ingress solution using BGP to advertise. And so it's like, okay, well, if I have my Kubernetes clusters in a cloud environment, not really applicable. This is really geared towards more on-premise Kubernetes clusters, where again, if you go back to some of the pictures I showed you, BGP and routing, typical on-premise Kubernetes clusters are going to connect to these massive data center networks or enterprise networks, and most of those large enterprise or data center networks are using BGP for routing. And so this provides that mechanism to hook those clusters into those existing data center and enterprise networks that use BGP, and then again, use BGP to advertise these load balancer service IPs and pod ciders.
Mm-hmm.
And we talked about 1.14 that was recently released. And this is a quick overview of the BGP enhancements. So improved configurability, so a lot of different timers that you can now expose or that are exposed that you could use when you're configuring BGP. Support for graceful restart. And so graceful restart allows BGP when, for example, Cilium is restarting. It allows BGP to say, hey, neighbors, or peers, right? I am getting ready to restart. Continue forwarding traffic. Don't don't go ahead and remove the networks that you learned from me. And then when I come back from my restart, having to go ahead and create the new neighbor relationships, advertise the networks, and have those peer BGP routers forward again. So really important tool for operationalizing BGP. But the other aspect too that you'll see here in the demo is just operational tooling, to being able to see, okay, who are my BGP peers? Am I receiving and sending networks? And then the IPAM integration. So a new form of IPAM called load balancer IP address management, or LBIPAM, allows us to create a block of addresses that will be assigned to services that are of type load balancer. And then BGP can go ahead and advertise those services. So we'll see that in the demo as well. And then eBGP multi-hop, this is, again, a configuration that allows BGP peers to be multiple hops away from each other and still peer with one another.
That's very cool. So basically, if I know my block IP block address, I could potentially tell the IPAM configuration to say these are the blocks I want to use for my external load balancer IP.
Right, and then that the integration between those two kind of components, right? The IPAM component and the BGP component, where the IPAM component basically says, hey, a controller will run, and when I create these IPAM pools, and the IPAM pools give it a name, and then say, here's the IP address block that I want to use to assign for services of type load balance. And then when the service of type load balancer is created, that gets assigned. And again, if you're running in a cloud environment, you're used to this, right? You just create a service and you look at the service and like, oh, it already has an external IP. Great, it's reachable, right? And so that integration between the LB IPAM and BGP, where IPAM assigns that address from the pool that you tell it to, and then BGP is able to go ahead and advertise that external IP that gets assigned to the service.
Yeah, that makes sense. I think you kind of answered the question I also wanted to ask you. What are the scenarios users want to consider enable BGP? I think you touched on for the cloud provider, they took care of this for us, right, in public cloud. So it's probably not very common you would need this with Cilium, but mostly for on-premise with enterprise who are setting up their own network and they have their own autonomous system. I think that's the words you used. Yeah.
Yep. Yeah.
All right. Thank you so much, Daniel, for that quick overview. Jason, I want to ask you about migration because you early on you touched on migration from other CNI to Cilium is very interesting and excites you. Can you talk a little bit about that feature?
Yeah, certainly. So we've all been in the Kubernetes landscape for a while at this point in time. Hopefully your organization's running a couple Kubernetes clusters. And a lot of the cloud providers are migrating or are starting to leverage or be compatible with Cilium. But that doesn't necessarily mean that all of the on-premise solutions are also going to be compatible with Cilium. I know I used to work at Rancher. Rancher had K3S, it had RK2. VMware has Tanzu. There are several other distributions out there. I know Canonical has K0S. They each have their own default CNIs. They each have the ability to extend the CNI. And so on a daily basis, if I'm trying to help somebody improve their networking stack, I'll run into several different CNI configs. And you can see the solutions that something with eBPF or some of the lower level networking components like BGP that you can get in these on-premise environments. But there could be a complicated migration path between where you are and where you're going. When I played around with them before, I think there's been a migration, the ability to migrate the Cilium CNI for a while now, maybe technically 2 years ago or so. A company actually put a blog post out there. Later, after we're done recording this, I can make sure that I post in the comments what that blog post was, in case anybody wants to look at that. But it was a very manual process. It was specific to an old CNI and very brittle. And so over time, the Cilium team has been introducing more usability aspects, and they're really making it really straightforward. So in the demo that I'll give later today, there's really just going to be a single resource that I'm deploying, and that single resource is going to take care of some robust updates that are then going to allow me to not have to provision a new EKS cluster or not have to provision a new RKE2 cluster just to start using Cilium and taking advantage of that. But then if, let's say, I have clusters that are spanning maybe nodes that have GPUs or nodes that have specific networking restrictions that I don't have on other node groups, Cilium is going to be respective of that. And so it's really the best of both worlds in that you can automate it as fast as possible if you just want to get through the process in a POC environment, or you can go through and methodically decide what sections of your environment are safe to migrate at this time. Make sure that you announce it to whoever's running on that environment, and then slowly and safely go in a highly critical environment to a new CNI.
Very cool. Yeah, sounds like you really piqued my interest to see the demo there. Thanks, Jason. Daneyon, is there anything else? You touched on IPAM early on. Is there anything else you want to add for IPAM before we switch to demo time? No?
No, not necessarily. I mean, I would just say generally the IPAM modes continue to evolve to solve more complex use cases. Like I said, the multi-pool IPAM, and we'll see here in my demo the load balancer IPAM. So typical Cilium, right? It just continues to evolve to solve more complex networking use cases. And so, yeah. about it.
In the context of IPAM, doesn't the ability to have a declared IP address pool help you with something like a cloud-based IP exhaustion? Couldn't you use some of the IPAM methodologies there to kind of extend your cluster to regions that it wouldn't normally go if you were using like a contiguous block of IP addresses?
Yeah, and I mean, I think most users will use private IPs for for their clusters, right? And then for advertising external services, that's where they'll create a load balancer IP pool of public addresses. Um, so yeah, I mean, again, I just think there's a lot of a lot of just different modes from the very simple that that Cilium can support, even from the routing standpoint, right? We talked about BGP, but BGP isn't enabled by default. It's something that you'd have to enable for Cilium. Even native routing isn't the default, right? So by default, Cilium uses tunnel mode, where each node is interconnected over Genevieve tunnel, but there's a reason why there's also native routing support, because just like what I showed you in some of those slides, is the internet wasn't built on IP tunnels, right? The internet was built on routing. And so if you want to scale environments, that's where customers, users are typically going to go with native routing mode for the performance and the scale.
So that's really interesting. So if I enable BGP, I think you said it's disabled by default. So if I opt in to enable BGP, does that mean the Kubernetes nodes within the cluster no longer using the tunnel between the Cilium nodes?
Yeah, if
Will they
you were to
use
enable
BGP?
BGP control, if you enabled BGP and and did not set native routing mode, you'd get an error, right? And so
Oh,
if you look at the BGP docs, it says, hey, this requires native routing mode. And so with native routing mode, typically what Cilium can do is each node that makes up the cluster will learn about the networks on the other node, right? The pod siders on the other nodes, right? Because when we think of a cluster of a bunch of nodes that all have a same kind of same IP network, but each of those nodes could have one or more pod siders that are different networks. And that's where, when you're using tunneling, right, it's all magic, right? Because when node one, when a pod one from node one wants to talk to pod two on node two using tunneling, by the time that packet leaves node one, it gets encapsulated into the IP address of that node, right?
yeah.
Whereas with native, right, that packet gets forward. It continues having that destination IP of pod two on node two. And so Cilium makes it really easy, where Cilium will dynamically learn about the pod networks on each of those nodes and program the routing table of each of the nodes. So all those nodes know, even in native routing mode, how to reach the pod siders of each of those different nodes. And then when we get to BGP, we start talking about, well, how do I get either these pod siders or the service IPs that abstract the pods? How do I get those outside of my cluster to potentially, so they're reachable from other clusters or anywhere outside of the cluster?
Very interesting. All right, let's jump to the demo time. Jason, I saw your screen is already up. Maybe you can go first to demo about the migration to Cilium CNI.
Sounds good. Right now on my screen, I've already got it pre-queued up with K9S. K9S just helps me visualize what's going on in my environment. But the basic idea here is that I have a K3S cluster that's running. It's running with its own flannel installation, and it's if we look at the pods, we can see over here on this, underneath this IP column, that the pod CIDR is 10.244 / something. That's where all my IP addresses are being formed as. And if I were to delete and provision a pod, we would see it gets repicked up as that new, as the same IP address. Basically, what I've done is I've taken the Cilium migration docs that they have on their website, and I've added them into something called the system upgrade controller. The system upgrade controller is a project under Rancher with K3s. Basically, what it allows you to do is declaratively write a script for updates that you can use against hosts. You could use it against the network, and basically, I'm just scripting the ability to go node by node and switch the CNIs out. The one part that I need from Cilium, I remember I said that there was one resource that we had to manage. Node config. We can see that there's a Cilium node config. Cilium node config is just going to allow us to carve out or to select specific nodes in the environment and change the config just for that node. And so throughout the whole process, what we're going to do is, and I'll switch over here.
So quick question, how do you know which node you are on for that Cilium node config?
So the Cilium node config right now is just selecting by labels, and none of the nodes in this environment have that label.
Okay, got it.
So the process of updating it is going to include adding a label to that, selecting a node, adding a label to that node, draining it, cordoning it so that no pods are running on that node, restarting the Cilium agent. Once the Cilium agent is restarted, then restarting the cluster or restarting that node. And then once the node restarts, we'll check and see that everything's up and running, and we should see new nodes form with the new pod, the pod IP. So we don't have to go over the specifics here, but basically the system upgrade controller uses resources called plans. That plan, you can define the concurrency. So in this case, I kind of want to do it a little cautiously, do it node by node. If I wanted to do it all at once, I could just say concurrency to the number of my nodes. I can choose which nodes I want to run on. In this case, my master nodes, my management nodes I'm not going to touch just because there's only one management node here. And if I take that down, bad things could happen, but I'll do that after I go through and I update the agents. There's a script that's stored in a secret, and then there's the upgrade command. Basically, the upgrade command is going to run in a container. The container is just going to shell out to this migrate.sh. And then if you look at the top, that's the secret. You can see that I'm labeling the node. I'm deleting the Cilium pod. I'm waiting for it to restart, and then we're restarting the node. So I'm going to apply that. Go back into K9s. We'll look at the pods. Hopefully down at the bottom, we should see a system upgrade, apply Cilium migrate K3s. That's generated by a job spec. So the system upgrade controller creates a job. That job goes through the node and makes sure that that's running. With that running, we should see, I'll make this a little bit smaller. We should see the Cilium node go through a restart. I think it might have done that while I was talking. We'll be able to see it on another node as it goes through. Once it's done that, it's going to restart the node. And because this is Kubernetes and it's declarative, when it restarts the node, it's not going to update it until the Kubernetes agent resubmits what its status is. So think of it as the node shutting down. The Kubernetes API still has information until it gets reset by the node. And then when the node eventually comes back up, we'll see the nodes, the pods are restarted, and those pods that are restarted have new IPs. This will take a little bit of time because this is a cloud environment. This is my local machine. These aren't Docker instances. These are actual VMs. I wanted to make sure that I was showing the actual VMs because in the Cilium documentation, I think it's just using kind just to prove it out. So you do a Docker restart instead of an actual system restart. But just know that since we are writing the script itself, it is flexible enough to do whatever restart command you need, depending on whether or not you're running bare metal, you're running in virtualized environments, or you're running in Docker.
So which CLI are you migrating from to Cilium?
Good question. So I had Flannel installed here. This daemon set here outlines that there's a Flannel daemon set, or Flannel for each node. And then you can see running alongside of it is Cilium. So the original state was that, there we go. The node reported that it didn't know anything about those previous pods. It's going to start the Cilium agent back up. And then the rest of the components are going to provision once they have a CNI to build to pull an IP from. But Cilium was installed, and so with that, we get the Cilium operator and the Cilium agents. Okay, so it's gone through and it's provisioned, or it's done the update on node 3. And so if I go through and I look at the IP address for the agent 3, we can see that it's now using 1042 as opposed to 10244, and that's the Cilium IP range. And so now, one of the benefits of the new Cilium migration strategy is with the Cilium node config that I have, I can actually communicate between this node, this resource and another resource running on the Flannel network. So throughout the whole process, because we're doing standard drains and coordinings, and because we are using networks that have the ability to communicate with one another, you're really reducing your downtime.
So quick question for you. You mentioned about that resource is selected by label. So did you actually, maybe I missed this when you were trying to show us the script on the apply migration, did you actually label the node one at a time until the Cilium migration finished? Then you went on label the next node?
So the cluster as I started didn't have any particular labels. In the plan, I said to choose all of the worker nodes, all of the nodes that aren't management nodes. And then in the script itself, what it'll do is the first step it'll take is that it will label the node, and then Cilium the Cilium node config is going to take over at that point. And so the Cilium configuration is going to be applied with the reboot of the Cilium agent. And that's what's allowing us to pull from this new IP space. And just to confirm, you can see that scheduling, and then the label here that's applied is Cilium default equals true.
Can you talk about downtime in this model? So I assume if I have my application pods running on the Cilium node, when it goes through the migration, I would have a little bit downtime. If I'm only have one replica, but hopefully if I have more than one replica and I spread out to different nodes, the downtime would be very minimum.
Yeah, if your workload can be shifted to other nodes, if you have the overhead to run them on, let's say, node 2 or node 3, and I'm trying to do node 1, it won't actually perform the restart until the node is deployed. And so you wouldn't get any interruption as long as you can deploy it on in the other node. If it's a specific node, maybe it's a stateful set or daemon set, you will have a little bit of outage there, just because the node is actually undergoing change, but it's minimized pretty far.
Okay, very cool. Yeah, thank you so much, Jason. This is a really interesting demo. I feel I learned a bunch of things about upgrade of Cilium and also migrate to Cilium CNI. I agree with you. The resource is very cool. Yeah, especially allow you to select by label for the node. Yeah.
Yeah, so if you're running in an environment that maybe you're using node feature discovery and those are already labeled, you could carve out sections based on what they're actually capable of. The one thing that, before I hand over the mic, I'll say is that currently in the script, if you look at the repository, or if we send the link out later, there's no validation being done against the new IPs. So it kind of just goes through the concurrency by itself. I would recommend that after the node comes back up, you double check that you're at least getting a pod from the new IP space.
Mm. Yeah, that's a great tip. All right, I'm going to send your demo link to the comments. I'd like to pass the mic to Daneyon. I believe he also has something very exciting to show us. Thanks so much, Jason, and Daneyon. Floor is yours.
Yeah, thanks, Lynn. Let me present do a screen share here. All right, so Lynn's going to go ahead and share this link to this demo that I put together, so everyone else can walk through it if you're interested. But just to do a quick introduction to the demo, we're going to go through the BGP control plane feature of Cilium, and this is what the demo consists of is a couple Kubernetes clusters, and each cluster running Cilium, of course, with multiple Kubernetes nodes in the cluster. And we're going to use Nginx to demonstrate connectivity. We'll use the deployment resource to run a couple Nginx pods, and then expose those pods using the service resource. And in these two clusters, these clusters are on separate networks, and there is an external BGP router that connects the two clusters. And so for the sake of time, I'm not going to walk through every step of this demo, but again, you should have a link if you'd like to do this on your own. Feel free to do so. But to walk through the demo, I've already installed the Kubernetes clusters, and it's important when when I create these clusters, I'm using Kind. This is all just done on my laptop. And what's important to note here is on the second cluster, we're actually creating a Docker network, and then what we do is we set this Kind experimental Docker network environment variable to the second network. And when you set that and you create the cluster, Kind will go ahead and create the second cluster on this separate network that I named Kind 2. We then install Cilium in each of the clusters, and as we've discussed, we have to disable tunnel mode, we have to enable BGP. This auto direct node routes, that's that feature that I talked about. Each node within the cluster goes ahead and exchanges the routes that comprise the pod CIDRs. So each node will dynamically learn about the pod CIDRs of the other nodes. We then, of course, make sure that Cilium status is good to go, and then we rinse and repeat for the cluster 2. And then the next phase, we run an external BGP router. I'm using Bird. Bird is software that can be run as a daemon on a Linux machine. So I have Bird just running as a separate Docker container. And one thing to note here, what you'll see in this repo is a Bird configuration file, which you'll want to update if you're going through this demo on your own, to update the IP addresses that Bird uses, as well as the peer IP addresses, which the peer IP addresses would be the nodes of the Cilium nodes in each of the clusters. And then you also need to make sure, since as the diagram showed, this router has 2 network interfaces one connecting to each of the clusters. You then add or connect this Bird router to the second Docker network. I've already run the sample Nginx apps in each of the clusters. I have confirmed that each of these pods within the cluster can communicate with one another. So we have confirmed intra-cluster communication. And then this is kind of where we're going to jump in and kind of go live with some things. So we talked about the Cilium Load Balancer IP pool, right? So this is going to allow Cilium IPAM to assign IP addresses to services of type load balancer. So let's go ahead and let me actually just show you really quick too what the environment looks like, right? So scroll up a little bit, and you see that my first cluster, which is called kind Cilium, I've got my control plane and worker nodes. You see that they're on the 172.22 network. And in my second cluster, named kind Cilium 2, I've got the 172.25 network for my 3 nodes. As I mentioned, I installed Cilium on both, check the status, so we're good to go there. Okay, get IP pools. I've got no IP pools, so let's go ahead and let's create, let me create here, copy. I'm going to create the IP pool in the first cluster. I'm going to create the IP pool in the second cluster. And let me actually really quickly too, so get service, get service, and you see that this service now has an IP from this pool, right? But if I do the same thing for my other service, like I said, I've already created these, get service, and in the second cluster, my Nginx load balancer services is pending an external IP. So now when we go ahead and create this, we can go back and we can see that Cilium has assigned an external IP.
Very nice.
And
By the way, is this everything on your laptop? Can I use this to assign external IP to my load balancer service in my environment on my laptop if I stand up a kind cluster?
yeah. So the next piece that we're going to get to is like, okay, now we have these IPs, but these IPs, even though they say they're external, yeah, they're external facing, but doesn't mean that they're reachable from anywhere. And that's what we're going to get into next, where BGP needs to advertise these. Now, in my simple little demo where, again, I showed you it's one external BGP router and 2 clusters, I'm just going to test connectivity from that external router to show you, like, let me actually show you now, right? So here's my bird BGP router that, again, it's just a Docker container, right? So this is all running on my laptop. I've got Docker running, and I've got essentially a bunch of Docker containers running on different Docker networks, right? And on this BGP speaking router, the only thing it knows about is its own default network and then its directly connected networks. Remember how I showed you the 172.22 network goes to cluster 1, the 172.25 network goes to cluster 2, okay? And I have configured this this BGP router to peer with my Cilium nodes for each cluster. But if I go into Word C and I do show protocols all, you're going to see that what I'm showing you here is the configuration, the running configuration of the Bird BGP speaking router. And so when I configured Bird, I said, okay, cluster 1 CP is short for control plane. So here's one of the peers that I want you to peer with: cluster 1 CP, cluster 1 worker, cluster 1 worker 2, right? So each cluster has a control plane node and 2 worker nodes. And the same thing for cluster 2 as I come through here. But what you're going to see here is that there's no routes being sent or received, and the BGP state is active. And if you're unfamiliar with BGP, you may say, oh, wow, that's really good. Actually, it's not. We want BGP. BGP needs to reach an established state for BGP speakers to start exchanging network routing information. But I just wanted to show you that. So let's go back to the IP route, and you see that the external BGP router has a configuration appears, but it's not receiving any networking information. It's not updating its routing table here. Right? When I go back to the view of my clusters, again, I've created the two load balancer IP pools, one for each cluster. What I could have done here too is the Cilium load balancer IP pool has a service selector field where I can use selectors to specify that, hey, only services with a particular label are allowed to use this pool. Okay, and so that allows us, again, more configurability of, okay, which services get which external IPs, right? But back to your question, right? Even though this external IP has been assigned, it's not reachable, right? I mean, it's pretty clear, right? If I try to, let me go ahead here, right? And just to show you, go back here and just curl nothing, right? Which it makes sense, right? Because when you look at this routing table, I mean, where this BGP router sending this is out Ethernet 3, which connects to the internet, and we know that these are non-routable, right? So it's sending it out E3, and the upstream router that connects to E3 essentially just dumps that packet. When this router should actually be sending it, to one of the clusters, actually cluster 1, which we'll see here in a second. So let's go back to the view of the clusters, right? So now that we have our load balancer IP pools, we see that the Nginx services are getting assigned an IP, but we need to now make that IP reachable. And I have already configured the Cilium nodes for BGP. That's the first step. You can get node. Let's just look at one of the nodes so you can see what it looks like. So these nodes, we go ahead and we annotate the node, and we say, hey, here's your autonomous system number. Here's your router ID to use, and here's the local port. So when you start getting a BGP peer that wants to talk to you, or you want to talk to your BGP peers, here's the local port that you're going to use. And get Cilium BGP policies. Let's take a look, right? There's no Cilium BGP peering, or excuse me, Cilium BGP peering policies for each of the clusters, right? And so this is the second step of the configuration where we get into. I already showed you this, right? You're going to go ahead and annotate the nodes in each of the cluster to tell those nodes what is their autonomous system. And in the demo, I didn't show it in the diagram here. Let me just scroll up really quickly. But the way that it's configured is this external BGP router is autonomous system number 65000, and then this cluster 1 is 65001, and this is 002. Okay, and you can see that here again as we get to the BGP configuration, right? Cluster 1, here's the autonomous system numbers of the nodes. And then I'm going to apply a single BGP peering policy that gets applied to all the nodes in the cluster. And Lin, as I mentioned, the service selector option that can be used with the load balancer IP pools, we can do the same thing with our Cilium BGP peering policies. So if I wanted to go ahead and say, well, I want unique policies for different nodes for whatever my use case may be, I can do that by using a node selector. Here I use a node selector, but you can see that it's matching labels. This is going to match all the nodes, right? So I can label the nodes with whatever I want, and then use this node selector within the peering policy. But the other aspects of this peering policy is we've got virtual routers. So a Cilium node could actually have multiple virtual BGP routers running on it. Here, we're just running a single virtual router And you see, since this is cluster 1, my local AS is 65,100. Same with the cluster 2, 65,200. And you see that these AS numbers match how I annotated the nodes. And then I'm going to create a single neighbor. And this is that external BGP router, the bird router that I showed you in the diagram. So let's go ahead and before I do this, let's see, BGP peers. You see for both clusters, and I can use this Cilium client and look at the peers for each of the clusters, and you see I have no peers, right?
Yeah.
So what I'm going to do now is, let's do a copy and create the peering policy for cluster 1. And now if I go back, let's see, BGP peers for cluster 1. Remember I showed you in the bird router of the session state as active. I said it's important. We want established, right? So now it's established. And you see that each node in this cluster has established a peering relationship with that bird external router. And you see that we are receiving and advertising networks.
Cool.
And now let's do the same thing for the second cluster. And we can see this as well. We now are established. And if we go back here, we should be able to see, and we do an IP route. Look at now, this external router knows about those networks.
Wow,
and
does that mean you can access it across different cluster now?
Yes, it'd be between clusters or anywhere, right? So obviously this is for demo, and this is a private network block, but in a normal, typical environment, these would be like publicly routable networks. And because this BGP router here, this external BGP router, only peers with the two clusters, it can't, it can't really go outside of this small little demo environment. But in a normal environment, you would assign the load balancer IP pools with publicly addressable IPs, and the BGP router, instead of having a single BGP router that only peers with the clusters, it would also peer with the rest of your enterprise network of other BGP routers, and all of those BGP routers would start advertising these networks, and then all of a sudden the whole world knows how to get to these services. Now, because again, it's just a small little demo environment, I should now be able to curl Nginx, right? And so now I'm able to hit the Nginx service on cluster 1, and I can also curl. Oops.
So this is from the VM on your laptop, I assume. Now you can reach out to the.
Yeah, this is instead of a VM, it's just a Docker container that runs Bird. And so part of the demo repo that if you haven't shared already, share.
Yes, I have.
Yeah, so you'll see there's not only the README that I've gone through with the instructions on how to run the Bird external BGP router, but it has a configuration file and so forth. And
awesome.
So this is all running locally on my laptop.
We have a question for you, Danny. I know we're running out of the time, but maybe let's take this question. So thank you, Rohit, for that question. Curious, how does this differ from Meta LB BGP mode?
Yeah, Rohit, thanks for the question. So very similar, right? So when Cilium first supported BGP in 1.10, it was through Metal LB integration. And then as time evolved, the use cases became more complex, and we couldn't use Metal LB to solve those use cases. That's when, I believe it was 1.12, the community said, hey, let's go ahead and let's create what's called BGP control plane, which is what we've been showing here today and talking about. And so with the latest release, between not only BGP support, but MetalLB also had what was called like a layer 2 support that ARP was used. There is a layer L2 announcement policy that Cilium now supports in 1.14, where you don't even have to use BGP. And this would be, simpler types of integration environments, smaller environments where you just use L2 ARPs instead of BGP to communicate. But what I would suggest is take a look at 1.14. If you're using MetalLB with Cilium, give BGP control plane a spin, and if you see that there is something missing, please let us know. But at this point, I think you can use BGP control plane instead of MetalLB if you'd like.
All right. Thank you, Daniel, for that answer. And thank you, Rohit, for the question. We appreciate that. I think it's time for us to wrap out the live stream. Thank you, the demo gods. I feel like the demo worked seamlessly for both of you. That's really impressive. It's so exciting to chat with both of you to learn a little bit more about Cilium, migrating from other CNI to Cilium to learn more about BGP and Cilium and how the IPAM address allocation policy works, and a really good job pulling out the demo together. Thank you so much, Daniel and Jason, and we'll see everyone in 2 weeks. Thanks everybody for joining. Bye now.
Thank you. Take care.